Hi everyone, my name is Lilson, and today I'll present the work detecting semantic conflicts via automated behavior change detection that I did in collaboration with Paulo Borba and João Moisés from Federal University of Pernambuco, Brazil, and Eduarda Mahmoud and Thorsten Berger from Chalmers and University of Gothenburg, Sweden. During collaborative software development, it's expected that different developers change different but related files during their individual contributions. However, when these contributions are integrated, different kinds of conflicts may arise. For example, consider this method build that returns an URL represented as a local variable request highlighted in red. In one contribution, let's call it left, the developer changes this local variable, adding a new question mark is highlighted in green. In another contribution, let's call it right, unaware of the change performed by left, the developer also changed this local variable, adding an equal sign is highlighted in purple. In both contributions, the method build still returns an working URL. The merge scenario happens and no merge conflict are reported as the current changes are not performed in consecutive lines. However, after the integration, the method build presents an unexpected behavior as the returned URL is not working anymore. And that's what we call a semantic conflict. The parent contributions worked fine, but when they are integrated, they change the program behavior in an unexpected way. Although all kinds of conflicts are supported by current and smart merge tools, semantic conflicts are not supported by them. A possible solution to detect these conflicts could be running project tests and expect the behavior change be detected by them. However, this idea directly relies on the quality and coverage of project test suites. But if we could create new tests exploring the change performed in the merge scenario. Based on this, consider applying Rendup or EvoSuite on the left commit of our motivating example, and as a result, the test case test1 is created, which compares the string returned after applying left change is highlighted in red, and the string returned by the method build is highlighted in green. Running this test case on the left, yield pass is expected. Run it on the base commit, yield fail, as the received string does not have the question mark. Run it again on the merge commit, yield fail, but this time because of the change performed by right, which were not expected by left. In this case, the equals sign. If we detect a test case that fails on base, passes on parent commit, and fails again on merge commit, a semantic conflict might be detected. In this way, a semantic merge tool could create and run tests during merge scenarios aiming to detect semantic conflicts. And this way, in this study, we aim to assess the detection of semantic conflicts using unit test generation tools. For that, we perform an empirical study analyzing change on same declarations in merge scenarios. For each merge scenario, we build the original and transformed version of these commits, creating our dataset. Next, we call Rendup and EvoSuite to generate test suites and run them. And finally, our scripts try to detect test cases that address our conflict criteria, and we also establish interference ground truth for this study by manually analyzing the change performed in each scenario of our sample. As a result, we classify 15 out of 40 changes with semantic conflicts. The generated test suite detected a semantic conflict in 4 of them. In this case, the parent contributions change the same string returned by the method toString, while left removes the reference from axis trees is highlighted in red, right adds a new reference for subscription is highlighted in green. The generated test based on the left commit compares the string returned after applying left change is highlighted in blue on the bottom, and the string returned by the method toString is highlighted in purple in the bottom. Running this test case on the base yield fail is the received string still has a reference from axis trees. Run it on the left commit yield path is expected, and run it again on the merge omit good file is the received string has a reference for subscription which was not expected by left. Aiming to understand the null detection for the remaining 11 cases of our sample, we manually analyzed the generated test suite for these cases. In this case, the tools were close to detect the conflict as the interferences propagated on the local variable events is highlighted in red. However, the assertion is highlighted in blue only checked whether this variable was not null. Adding a new assertion is highlighted in blue on the bottom. Exploring the size of this variable event would have been enough to detect the semantic conflict. In this another case, the object holding the semantic conflict was created with irrelevant values is highlighted in red. As a result, the interference location of the semantic conflict could not be reached during the test case execution. Creating object with relevant values is highlighted in green on the bottom is required to at least reach the interference location in this case. In the same scenario, the method holding the semantic conflict was void, so the test case focused on catching exception that could be thrown during the test case execution is highlighted in red. However, the interference is propagated on the first object, saying this parameter for the method holding the semantic conflict is highlighted in green on the bottom. Adding a new assertion exploring the contents of this object would have been enough to detect the semantic conflict. For the 25 cases that we classify without semantic conflict, our script did not report any test case that could address our conflict criteria, so for this study we do not report false positives. In a nutshell, semantic conflicts are hard to be detected as current and merge tools are not able to deal with them. A semantic merge tool could detect these conflicts, as we show here, using regression testing and unit test generation tools. These tools have some limitations regarding test generation that we initially try to understand here. And as a final contribution, we provide our sample of semantic conflicts as a dataset with executable bit files and interference ground truth. Instructions to replicate our study or run a new one using our scripts are available in our online appendix. Thank you.